You know, usually when you talk about looking at a map, there's this inherent expectation of finality to it.
Right, like you'll eventually reach the end of the detail.
Yeah, exactly. Like zooming in on a digital map application on your phone, you start looking at a whole continent, then you pinch the screen to go down to the city level.
Then the street, then the house.
Right. And eventually you hit the ultimate limit, the pixel. It's clean, it's finite, and you reach the fundamental building block of the image.
I mean, it is really comforting to think about reality that way.
Hmm.
We inherently desire our physical universe to have a definite, solid foundation.
A floor that we can stand on and say, this is the smallest thing that exists.
But then you step into the world of theoretical physics, and suddenly that neat little map completely shatters.
It really does. And that brings us to our deep dive today. We are looking at a scientific landscape right now that is honestly in crisis.
A pretty severe crisis, yeah.
We've got a massive stack of material on the table for you today. We're pulling from historical notes on quantum mechanics, decades of theoretical physics journals, and at the center of it all, a really controversial, revolutionary paper.
Yeah, it's called Infinite Fractal Descent. Redefining the strong interaction in space-time curvature through scale-invariant logarithmic geometry.
Right, by Enkamala Nasenjargal. And the mission here for this deep dive is to explore a framework that completely challenges the very foundation of how you perceive reality.
It forces you to rethink literally everything.
So let's start by laying out the century-old crisis. Why is unified physics currently stuck at a dead end?
Well, to understand the roadblock, we really have to look at the two towering pillars of modern physics, which unfortunately just refuse to speak the same language.
They hate each other.
Basically, yeah. On the macro scale, the majestic dynamics of the cosmos, planets, galaxies, Einstein's general relativity works flawlessly. It treats gravity as this continuous deterministic force. Think of a heavy bowling ball sitting on a taut trampoline. It smoothly curves the four-dimensional fabric of spacetime.
Okay, so it's a smooth, continuous, and highly predictable manifold.
Exactly. But on the other hand, we have the microscale, the standard model of quantum mechanics, which also works flawlessly when describing atoms and subatomic particles.
And it uses totally different rules.
Completely incompatible philosophy. It views the fundamental forces of nature not as smooth curves, but as discrete, probabilistic, quantized exchanges of tiny particles.
Right, the chunks.
And these particles operate on a completely flat, rigid background. They don't bend space at all. They just play out on a static stage.
So you've got a smooth, bending trampoline on one side and a rigid, static stage covered in chunky pixels on the other.
Right. And the real schism happens when you force those two frameworks to interact at the ultimate resolution limit of the universe.
Which is that microscopic threshold we call the Planck scale, right?
Yes. If you try to calculate the gravitational pull of a single, localized quantum fluctuation, the smooth equations of general relativity try to wrap around an infinitely small, chunky quantum point.
And what happens?
The math catastrophically collapses. The equations just start spitting out nonsensical infinite densities and impossible singularities. The numbers just break.
Wow. And for decades, the orthodox approach has been trying to force-fit gravity into that discrete, microscopic box, right?
Yeah, it's where you get string theory or loop quantum gravity. They're trying to find the pixel of gravity.
But the infinite fractal descent framework, let's just call it IFD, comes in with a totally radical premise.
It really is a paradigm shift.
It asks, what if the universe isn't artificially split between a macro continuum and a micro quantum realm? What if the universe operates under a recursive, scale-invariant logarithmic geometry?
Meaning the rules don't change just because you get smaller.
Exactly.
The IFD paper argues that to solve an impossible mathematical breakdown, we cannot keep trying to build macroscopic space upwards from tiny, hypothetical vibrating strings or one-dimensional loops.
It takes a different angle entirely.
Right. IFD looks to the history of physics and applies a strictly top-down geometric rule.
Because breakthroughs in physics don't always start with knowing every tiny mechanical detail of how a system operates, do they?
No, not at all. Sometimes you just have to draw a hard line in the sand first. History shows us that major physical breakthroughs frequently start by imposing absolute geometric boundaries.
Even before the underlying mechanics are fully mapped out.
Exactly. Look at the ultraviolet catastrophe at the dawn of the 20th century. Classical models predicted that a theoretical object called a black body would emit infinite amounts of high-frequency energy.
Which obviously doesn't happen.
Right. So Max Planck resolved this infinite paradox using a top-down approach. He simply postulated that energy must be quantized into distinct
He
packets.
didn't even know why, right?
He had no idea what the exact physical mechanism inside the atom was that caused it. But he knew that imposing that universal boundary condition was mathematically necessary to save the universe from infinite divergence.
And Einstein pulled a really similar move with light. He didn't start by explaining the mechanical ether of space. He just assumed the speed of light in a vacuum was an inviolable absolute limit.
Yes, and from that top-down absolute rule, he deduced special relativity.
Okay, so IFD follows that esteemed tradition. It posits a new absolute law.
Universally applicable Fractal density boundaries.
Yeah.
And they are governed by a strict mathematical constant.
So how does this boundary actually work in IFD?
Well, the paper draws a parallel to how we currently map macroscopic astrophysics. Giant structures like galactic superclusters and cosmic voids are mapped using what are called primordial Gaussian density fields.
So the early universe is treated as this vast, continuous, fluctuating ocean of mass energy.
Precisely. Like looking at a topographical map of a mountain range.
Yeah.
You have random peaks of high density and valleys of low density.
Got it.
Within that fluctuating cosmic ocean, any spatial peak that crosses a strictly fixed density threshold becomes a stabilized structure. It just collapses under its own gravity to become an observable thing.
Like a galaxy.
Like a galaxy.
Yeah.
And the IFD framework takes that exact macroscopic mechanism and radicalizes it by extrapolating it directly down to the subatomic scale.
Okay, wait, meaning subatomic particles aren't just solid, discrete things that got dropped onto the empty fabric of space?
Not at all. Quarks and electrons are not distinct species of fundamental matter overlaid onto a static background. In IFD, they are highly localized, extremely overdense peaks within the dynamic space-time density field itself.
Oh, wow. So they're simply microscopic peaks that happen to cross a critical quantum threshold.
Exactly. And once the density of that peak crosses the limit, it topologically collapses into a stabilized microvortex.
Let me use that digital photograph analogy from earlier, but twist it a bit.
Go for it.
Zoomed out, you see a smooth, continuous image of a landscape. That's general relativity. You zoom in far enough, and the image breaks into distinct, tiny squares or pixels. That's quantum mechanics.
Right. Standard physics says the pixel is the end of the road.
But IFD is suggesting that if you look closely at the boundary of that single pixel, it's actually a gravitational funnel. And if you fall down that funnel, you land in an entirely new, deeply nested photograph.
Zooming down forever. Yes. That beautifully illustrates scale invariant fractal recursion. The rule applies no matter the magnification.
So if fundamental particles are just localized peaks in a continuous field, we have to talk about what happens at the center of the most extreme density peaks in the universe.
Black holes.
Black holes, because standard physics sees a massive brick wall there.
It really does. Under standard astrophysical models, the math behind a black hole event horizon mandates impossible conditions.
How so?
Well, physics dictates that the radius of an event horizon is linearly proportional to the mass enclosed within it. But volumetrically, mass is proportional to density, multiplied by spherical volume.
Okay, tracking with you.
If you trace a collapsing star backward to its microscopic inception point at the center, the volume shrinks to zero while the mass remains. Any number divided by zero approaches infinity.
So the internal density is mathematically mandated to hit true infinity.
Yes. Which gives us that catastrophic breakdown again, the singularity.
A point of infinite density and zero volume where standard models claim all the material that made up the collapsing star is entirely thermodynamically destroyed.
And that concept of a zero-dimensional singularity has stalled physics for a century because it creates the black hole information paradox.
Right, because quantum mechanics states that physical information, like the complex quantum state of the matter falling into the black hole, cannot be permanently deleted from the universe.
Exactly. If a singularity crushes matter out of existence, we violate a core law of physics.
So how does IFD bypass the paradox?
By stating that this absolute density limit is not a fiery destruction of matter, it's actually a topological phase transition boundary.
A phase transition.
Yeah. When the localized density of a collapsing star hits the Planck limit, the spatial curvature literally punches through our dimensional fabric. It creates a highly stable topological microvortex.
And this vortex acts as the physical entrance to a smaller, deeply nested fractal scale.
Precisely. The baryonic matter's immense localized energy, its complex entropy, and its informational geometry are fundamentally conserved. They don't vanish.
They seamlessly translate into the geometric baseline of the next descending fractal layer.
Yes. And this concept powerfully aligns with these Strominger-Vafa computations from string theory.
Oh, right. I remember the paper highlighting those computations. They proved mathematically that event horizons must contain incredibly intricate, microscopic degrees of freedom encoded on their surfaces, right?
Exactly. The Strominger-Vafa work suggests an event horizon is incredibly complex, but standard physics doesn't know where to put that complexity if the inside is just a dead infinite point.
But IFD gives it a home.
It does. In IFD, those microscopic degrees of freedom are literally the functioning structures, stars, galaxies, complex matter existing entirely within the newly descending fractal universe housed inside the vortex.
That is mind-bending. But hold on, I need to push back here a little bit.
Sure.
If it's essentially a trap door dropping into a new microscopic layer of reality, why doesn't everything just fall through instantly? Like, the whole universe should just drain down the drain pipe.
That's a great question.
There must be some mathematical gatekeeper controlling what drops and when, right?
There is. The universe would indeed drain away without a strict gatekeeper. And that brings us to the mathematical engine of the IFD framework, the fractal density constant.
The gatekeeper.
It controls the threshold. The foundational equation defining this topological relationship is an integral that utilizes a natural logarithm.
Okay, lay on us.
Specifically, it relies on the natural log of the fraction, rho sub s divided by rho sub p.
Let's translate those variables into physical concepts so we can all wrap our heads around it. What is rho sub s?
Rho sub s represents the measured energy density of a strictly localized event. So that could be the core of a collapsing massive star or the collision point of two high-energy particles.
And rho sub p.
That is the Planck density. That is universally accepted as the absolute theoretical maximum density limit permissible before space and time as we know them break down.
So we have the local density over the maximum possible density. As long as the local event is less dense than the absolute limit, that fraction is a decimal less than 1.
Exactly. And mathematical rules dictate that the natural logarithm of any fraction between 0 and 1 yields a negative value.
And what does a negative value mean for reality?
In the language of spatial topology, a negative curvature value mathematically defines a hyperbolic geometry. It translates physical space into a complex saddle shape, or more simply, a steepening funnel.
So this creates the throat of the gravitational well.
It does.
But let me stop you there. I understand the math getting smaller on paper, but how does a logarithm equation on a chalkboard literally carve a funnel out of physical space? Math is just numbers. How does it physically bend reality?
Well, in general relativity, math and physical geometry are identical. The math operates through what are called metric tensors.
Which are like instruction manuals.
Basically, yes. They are instruction manuals telling the fabric of space how to measure distance and time at any given point. When the logarithm outputs a negative curvature value, it alters the metric tensor.
It literally tells space to stretch.
Yes. Distances become longer the deeper you go.
Like stretching a sheet of heavy rubber downwards. The harder you push, the steeper the sides of the funnel get.
Exactly. But the crucial moment occurs at the mathematical limit. As the local density maximizes and reaches the absolute Planck limit, the local density equals the maximum density.
So the fraction becomes exactly 1.
And the natural logarithm of 1 is 0.
Zero curvature, meaning exactly at the precise moment of maximum energy density, the localized spatial curvature abruptly flattens out relative to our layer of observation.
Yes, that mathematical flattening is the trigger. It forces the concentrated mass energy to instantly invert topologically.
So instead of the rubber tearing at an infinitely sharp point,
The geometry is forced to descend through the 0-point boundary. It drops into the deeply nested hyperbolic dimension.
wow.
And because this integral operates over a closed, localized volume, it proves this phase transition isn't just an instantaneous microscopic dot. It's a dynamic action across a definable topological space.
Forming the outer event horizon boundary of the microvortex.
Exactly.
It's mesmerizing. It's like the bottom of the torn funnel seamlessly opens up, becomes the ceiling of a brand new room underneath.
a very eloquent way to put it.
And this realization that extreme gravitational curvature opens these microscopic vortices, it completely upends the way we understand the forces operating inside normal atoms, doesn't it?
Oh, completely. The implications here unify physics by tearing down the walls between different forces.
Let's talk about the strong nuclear force.
Right. Currently, the strong nuclear force, which is the immensely powerful force that binds quarks together inside a proton, is modeled by quantum chromodynamics, or QCD.
And QCD models this binding force as a continuous dynamic exchange of discrete virtual particles, right? Gluons.
Yes, standard model physics basically visualizes a proton as a tiny bag of discrete quarks tossing glowing gluon particles back and forth to stay glued together.
But IFD rejects that mechanic entirely.
Completely. The paper posits that the strong nuclear interaction is not a fundamentally distinct physical force mediated by quantum field particles.
Then what is it?
It is simply the extreme mathematical manifestation of standard macroscopic gravity acting at a fractal boundary. A subatomic particle is not a bag of quarks swapping gluons, it is a microscopic black hole.
It is a topological microvortex governed entirely by extreme spatial curvature. That is wild.
And replacing discrete force particles with pure geometry brilliantly solves two deeply counterintuitive quantum phenomena that standard QCD struggles to explain elegantly.
Let's unpack those. The first is asymptotic freedom, right?
Right. Asymptotic freedom dictates that quarks behave essentially as perfectly free, non-interacting particles when they are in extremely close physical proximity to one another.
Which seems backwards. But in IFD, this behavior is a natural geometric consequence.
Exactly. When quarks are extremely close, they are deep within the narrowest throat of the microvortex. The localized density is highly concentrated, pushing that logarithmic ratio toward 1.
Which flattens the spatial curvature relative to the quarks themselves.
Yes, they experience negligible structural resistance because they are simply hovering together at the flattened bottom of a deep gravitational well.
So they're free to float at the bottom of the crater.
Exactly.
But then there's the flip side of that. Color confinement. As the physical distance between quarks increases, the force binding them doesn't weaken like a magnet would. It gets immensely strong.
So strong that you cannot isolate a single quark anywhere in the observable universe.
And standard QCD clumsily models this phenomenon by inventing gluon flux tubes.
Right. They theorize these strings of strong force energy that physically stretch like rubber bands between quarks.
But under IFD, there are no quantum rubber bands snapping inside the atom.
None. IFD replaces the convoluted mechanics of virtual flux tubes with clean topological spatial curvature.
So quarks can't be separated because...
Because as you try to pull them apart, you are literally forcing them to climb up the incredibly steep, exponentially increasing geometric walls of the microvortex throat.
It acts as an impenetrable, hyperdense gravitational wall.
The closer they get to the macroscopic boundary above, the steeper the gravity gets.
Okay, wait, I have a major question about that, actually.
Right.
If it's just a ridiculously steep gravitational crater, why does pulling on it hard enough create entirely new particles out of thin air? When they smash protons together in colliders, standard physics says the rubber band stretches until it snaps, and the energy from the snap creates new quarks.
Right, the snap.
So how does pure geometry create new matter?
It comes back to the concept of the vacuum field. IFD argues that when immense external kinetic energy is applied to try and separate the quarks, you are applying massive stress to the local geometry.
The geometry of space itself.
Yes, the extreme geometric tension eventually forces the localized quantum vacuum energy to relieve the stress by carving out new adjacent microvortex.
Oh, so you aren't snapping a physical tube.
No, you are inducing a new localized geometric phase transition. The tension forces the surrounding space to buckle and form a new funnel.
Okay, that brings up the absolute elephant in the room. If fundamental particles are essentially microscopic black holes acting as geometric funnels, why haven't the massive particle colliders at CERN seen these trapdoors opening? We smash particles together all the time.
The answer lies in the subatomic resolution barrier. The collision energies achieved at the Large Hadron Collider are astonishingly high relative to biological scales. They hit up to 14 tera-electron
That
volts.
sounds huge.
It does. But that energy level remains many, many orders of magnitude below the absolute threshold of the Planck density.
So we are essentially hitting a titanium vault door with a rubber mallet.
That's a great analogy. The full mathematical threshold required by the IFD integral is simply not being met. Current LHC collisions are violently denting the fractal boundary, yes.
But they completely lack the sustained, hyper-concentrated energy required to properly pierce it and stabilize a vortex.
Exactly. And to prove this isn't just a convenient theoretical excuse to hide behind, the paper points to macroscopic analogs studied by CERN, the University of Helsinki, and the Hebrew University of Jerusalem.
Right, they researched extreme vacuum plasma arcs.
The parallels in plasma physics are highly verified. If the active density threshold of a highly localized high-energy plasma arc drops below a mathematically critical limit, the surrounding vacuum environment abruptly and aggressively recovers its baseline dielectric properties.
It instantly snaps the electrical bridge shut.
Yes.
Think of it like trying to permanently poke a hole in the surface of a swimming pool with your finger. You can dent the water violently, but the second your finger slows down even a fraction, the surface tension of the water snaps back aggressively.
Exactly like that. The dielectric property of the spacetime fabric heals itself before our scientific instruments can ever catch the microvortex stabilizing.
Wow. So the universal spacetime fabric acts precisely like a high-tension vacuum dielectric medium. We merely dent it in our colliders, and it snaps back into a flat state with extreme prejudice.
Terminated the structural phase transition before a stable microscopic event horizon can be observed.
Incredible. Now, we've spent this whole time scaling down into the quantum realm. But if this geometric rule is truly scale invariant, it must also scale infinitely upward to the macroscopic universe.
It absolutely has to. By definition, a universally applicable geometric rule necessitates a profound reevaluation of macrocosmology.
And applying IFD upward leads directly to the death of dark matter.
It really does. Currently, cosmologists use invisible dark matter as mathematical filler. When we look at galaxies spinning, the observable luminous mass, the stars and gas, doesn't generate enough gravitational pull to keep the outer edges of the galaxy from flying apart.
So standard physics invents an invisible halo of dark matter to glue it all together.
But under IFD, macroscopic gravity isn't just a weak emission emanating from chunks of mass. Gravity is dynamically defined as the relative strength of spatial curvature between nested layers.
Meaning entire swirling galactic clusters operate as immense macrovortices.
Exactly. The geometry of the galaxy itself is a giant funnel holding everything inside.
So the anomalous rotational velocities at the outer edges of galaxies
Are perfectly explained by the steepening logarithmic spatial curvature of the macrovortex. We do not need hypothetical dark matter particles.
so-called WIMPs, right?
Yeah.
Weakly interacting massive particle.
Right, we don't need them. The galaxies hold themselves together through pure logarithmic geometry, exactly the same way the microvortex holds the quarks together inside a proton.
And this connects perfectly back to the Gaussian density fields we discussed at the start of the deep dive.
It ties it all together. The primordial density fields that created our cosmic voids and galactic peaks are not a random cosmic coincidence. They are a strictly universal, fundamental geometric property.
So the chaotic quantum vacuum fluctuations we observe under a microscope, the constant popping in and out of energy,
Are the exact mathematical analog of this vast cosmic field, just repeating endlessly on a smaller scale. A fundamental subatomic particle is structurally identical to a swirling galactic cluster.
But let's follow that logic to the absolute extreme. If galaxies are essentially macrovortices and subatomic particles are microvortices, what about the violent, matter-crushing, supermassive black holes at the center of active galaxies? Are they feeding a larger fractal structure above us?
The framework strongly implies it, yes. Matter violently approaching the theoretical infinite density limit near an active galactic center does not face thermodynamic annihilation.
It forcibly crosses the extreme fractal density boundary.
And seamlessly populates the complex geometry of a vastly nested dimensional layer beneath it. It fundamentally rewrites the cosmic life cycle.
So matter is not destroyed. It continuously cycles physical information across extreme dimensional boundaries.
Exactly.
We have taken a massive intellectual journey over the last few minutes. We've taken a chaotic universe filled with snapping quantum rubber bands, mathematically impossible singularities, and invisible dark matter.
And replaced it with a deeply elegant, deterministically governed, scale-invariant logarithmic geometry.
Everything from the quarks making up your body to the swirling galaxies you see in the night sky operates by the exact same topological rules.
And this extends far beyond philosophical musing. Applying this rigorous geometric framework to disciplines like nanotechnology and advanced computational architecture could fundamentally guide quantum gravity research out of a century of mathematical stagnation.
It provides a purely geometric, logical understanding of reality. It's an incredible paradigm shift.
It really is.
We will leave you with a final mind bender to mull over. If IFD is right, if every single subatomic particle is essentially a microvortex containing a vast, nested fractal universe, and if our own galaxies operate as massive macrovortices, look up at the night sky.
Yeah.
Is our entire observable, seemingly infinite universe nothing more than the microscopic inside of a single subatomic particle housed in an unimaginably massive higher dimensional layer? Think about that next time you look at the stars.